In this lesson, we are going to talk about how to use tree diagrams to solve probability problems. Let's start with this example. A bag contains 5 red balls and 3 green balls. A ball is drawn at random and then replaced. So let's draw a tree diagram. This is for the first row. After the first row, what can we get? What colors can we get? We can get a red color, or we can get a green color, right? This is the first row. For example, in the first row, we got a red color ball. Then in the second row, what can we get? Again, we can get a red color, or we can get a green color. This is the second row. Let me write second row. Let's say that in the first row we get a green color ball. In the second row, what can we get? So we have 2 colors of balls, right? Red and green. So in the second, we can also get a red ball or a green ball. This is the second row. So these are all possible outcomes. If we travel this way, in the first we can get a red, and in the second we can also get a red. So we can get, let me write, probability of getting a red and then a red. Or we can get red and then green. Or we can get green and then red. Or we can get green and then green. Okay? These are all possible outcomes. Now, in the first row, what's the probability of getting a red color? Totally, how many balls do we have? 5 plus 3, 8. So, we write the number of all balls in the denominator because it is the number of all possible outcomes. In the numerator, we write the number of desired outcomes. In the first row, what is the probability of getting a red ball? The number of red balls, 5 over 8, is the probability of getting a red ball in the first row. What is the probability of getting a green ball in the first row? So that's going to be 3 over the number of all balls. That's going to be 3 over 8. Okay. In the first row, we got a red ball, let's say. And we replace it. That means the number of red balls does not change because we replace it, right? And the number of all balls also does not change. In the second row, what's the probability of getting a red ball? It is the same, 5 over 8. The probability of getting a green ball, because the number of green balls and all balls does not change, it is also 3 over 8. And the same idea applies here, 5 over 8 and 3 over 8. Okay, now, what is the probability of getting a red ball in the first and another red ball in the second row? In the first, I want to get a red ball. In the second, I want to get also a red ball. So we just multiply these 2 probabilities. 5 over 8 times 5 over 8. The probability of getting a red ball in the first, but a green in the second. So that's going to be 5 over 8 times 3 over 8. The probability of getting a green ball in the first, green, and then red. So that's going to be 3 over 8 times 5 over 8. 3 over 8 times 5 over 8. And go ahead and tell me, please, what is the probability of getting green and green? In the first, we want to get a green ball. It is 3 over 8 times. In the second, we want to get also a green ball. So it is 3 over 8. So whichever way you are traveling, you are just going to multiply the probabilities on the way. Okay? What is the question? The probability that both balls are green. So this is our question. Green and green. 3 times 3, 9. Over 8 times 8, 64. So 9 over 64 is the answer for this question. Alright then, let's do the second example. A bag contains 5 red balls and 3 green balls. Again, we are going to draw a tree diagram, but now we select a ball at random and then we don't replace it. That means the number of balls will be changed in the second draw. Okay. So let's do it here. Let me write here 5 red balls and 3 green balls. And then let's draw the tree diagram first. In the first row, I can get a red ball or a green ball. If I get a red ball in the second row, I can get a red ball or a green ball. Or if I get a green ball in the first row, in the second try, I can get a red ball or a green ball. If the question says, for example, 3 green balls, then we are going to keep going. We just make more diagrams, okay? Make more diagrams. Do you see? Okay then. Now, what is the probability of getting a red ball in the first try? 5 over the number of all balls is 8. 5 over 8. What is the probability of getting a green ball in the first try? 3 over 8. Let's say that we got a green ball in the first try. Now, red ball. The number of red balls will be decreased by 1, right? So now I will have 4 red and 3 green balls. So in the second try, I want to get a red ball. I have 4 red balls and total number of balls is 7. So again, be careful. In the question, if it says replaced, then it was going to be just like in the first example. But now it says not replaced. So the number of red balls changed, the number of all balls changed. So please go ahead and tell me what is the probability of getting a green ball if we get a red ball in the first selection. Now please tell me this. I didn't hear. 3 over 7, yes. 3 over 7. Alright, so now we are done with this. We have 5 red balls and 3 green balls. In the first row, we got a green ball. Now, the number of green balls will be 2. 5 red and 2 green, right? In the second try, I want to get a red ball. What's the probability? 5 reds over the number of green balls, 2, total number of balls, 7. And 2 over 7 is going to be the probability of getting a green ball in the second try. Is there any question you want to ask in this diagram?
No.
Alright then, let's look at the questions. What is the probability of getting 2 green balls? 2 green balls. In the first, I want to get a green. In the second, I want to get also a green. So I travel this way, right? I multiply all the numbers on the way. Okay? That means this is A, probability of getting a green and then a green. That's going to be 3 over 8 times 2 over 7. So we can simplify 2 and 8, divide by 2, 1 and divide by 2. 4, 3 times 1 is 3, over 4 times 7 is 28. Now let's do B. I want to get 1 red ball and 1 green ball in the second example. So what is this outcome? Red and red, right? This outcome, red and red. What is this outcome? Red and green. Red and green. What is this outcome? Green and red. Green and red. And what is this outcome? It is green and green. I want to get 1 red ball and 1 green ball. So which of these satisfies that condition? 1 red, 1 green. It satisfies that. And it satisfies that. So now what should I do? Which one should I use? Both of them satisfies. In this example, the order does not matter. But for example, in another example, it may say, in the first, I want to get a red. In the second, I want to get a green. So now we are going to use this. Or it may say, in the first, green. In the second, red. So this is going to be the probability. But it says 1 red ball and 1 green ball. That means we just add them together. Okay? So let me write here. B. Probability of getting 1 red, 1 green. That's going to be the probability of getting red ball and green ball plus the probability of getting green ball and red ball. So this is going to be 5 over 8 times 3 over 7. 5 over 8 times 3 over 7 plus, and green red, green and then red, 3 over 8 times 3 over 8 times 5 over 7. 5 over 7. So multiply the numerators. 5 times 3 is 15 and denominators 8 times 7 is 56 plus 3 times 5 is 15 over 8 times 7, 56. We have the same denominators, so we just add the numerators. 15 plus 15 is 30 over 56. And now we divide both numerator and the denominator by 2. 30 over 2 is 15 over 56 over 2 is 28. It's going to be the answer to the second question. That means if I want to get 1 red ball and 1 green ball, the probability is going to be 15 over 28. So 15 over 28. What was the answer for the first? It was 3 over 28. Third example, this is our last example. A bag contains 7 green discs and 3 blue discs. A disc is drawn and not replaced. A second disc is drawn. Copy and complete the tree diagram. So the tree diagram is already given here, as you see. In the first, we can get a green disc or a blue disc. And then in the second, we can get a green disc and a blue disc. Or if we get a blue in the first, in the second, we can get a green disc or a blue disc. Okay? So now, we are going to complete this tree diagram first. 7 over 10 is clear, as you see. 7 green discs, 3 blue discs. We just add them together. 7 over 10 is the probability of getting a green disc in the first draw. In the first draw, the probability of getting a blue disc is going to be 3 over 10. Now, after getting a green, so now we have 7 green and 3 blue, right? In the first, if we get a green, then we are going to be left with 6 green and 3 blue, right? Because it is not replaced. So now, in the second, I want to get a green. So 6 over total number of discs, 9. 6 over 9, as you see already written here. But if I get a green disc in the first, what is the probability of getting a blue disc in the second? 3 over 9 will be the probability of getting a blue after getting a green. Again, in the first I got a green, 7 over 10. In the second, I want to get a blue. It is going to be 3 over 9 because I have 3 blue but 6 green because it is not replaced. Okay, now we are done with this. Now, at first we have 7 green and 3 blue. But in the first I got a blue, so it is not replaced. I got 7 green and 2 blue. Okay? So now, in the first we got a blue. In the second, what's the probability of getting a green ball? We have 7 green balls. 7 over the number of all balls is 9. 7 over 9. In the first, if we get a blue, in the second, what's the probability of getting a blue ball? It's going to be 2 over 9 because we have 2 blue and total number of balls is, or discs, doesn't matter, it is 9. 2 over 9. Now let's look at the question. What is the probability that both discs are green? The first will be green and then the second will be green. The first will be green, you see that? The second also is green. So we multiply these numbers, 7 over 10 times 6 over 9. So let me do A here. 7 over 10 times 6 over 9. And now let's do simplification. Divide by 3, 2, and divide by 3, 3. And these are divisible by 2, divide by 2, 1, and divide by 2, 5. So 7 times 1 is 7 over 5 times 3 is 15. This is the answer to the first. Now let's look at the second. B. The probability of getting both discs are blue. So let me make it another color. Let me make it yellow. Blue. In the first, I'm going to get a blue. In the second, I'll also get a blue. Okay? I'm doing B. So in the first blue, 3 over 10 times in the second blue, 2 over 9. Okay? Now let's simplify. First, 3 and 9 simplified. We got 1 and 3, both of them divisible by 3. And here, both of them divisible by 2, divide by 2, 1, divide by 2, 5. 1 times 1 is 1 over 5 times 3 is 15 is going to be the answer. So the first 7 over 15 and the second 1 over 15.